unique solution to two lines. We're just looking at 3D for the moment. 2D for the moment. A unique solution just looks like this. Two lines, and where they intersect is that unique solution. Infinite solutions, what does that look like? Perfect, well done, guys. So the first line looks like that. The second line looks like that. So they are the same line. So another way of saying this, the lines are coincident. What does it look like? No solution. No solution, they never intercept. Saddest love story ever, yeah? They're just always watching each other for eternity. Okay, so again, the A matrix is singular and they're parallel. And if you think of them in terms of y equals mx plus c, the gradient is the same. So how do we solve a linear equation using matrices? Do you remember? We did it. Perfect. Okay, so the first step, which I do, before I even start to solve, is what do I need to think about for one of those matrices? Remember the three cases. Perfect. Okay, so we do the determinant of the A matrix. Because if it's singular, there's no real point rearranging and finding the inverse and stuff like that. Does that make sense? So first step is the A matrix singular. So we have to actually construct the A matrix so the people looking at our working out know what we're talking about. So these are the coefficients, yeah, in front of x and y, x, y, x, y. And you guys remember the X matrix. We'll have a look at the two equations. Hopefully it's pretty obvious. One is just 3 times another one. So if you can recognize that, it's a good way to check. You should get a singular matrix. Anyway, let's do it anyway. So the determinant is this one times this one. Do you remember this? Unit 2, I think. This one times this. So the diagonal minus the diagonal. So you got 24, negative 24 plus 24, which is 0. So it is singular. It's the multiple. So do you remember what I said? Probably not. It's either going to have the same gradient and the same intercept, or just the same gradient. So imagine like you're showing a grade 10 student. What would you do to show it's the same gradient and same intercept? Perfect. So that's the second step. If it's singular, put it into y equals mx plus c. So the first equation, bring that 2x over, and then divide by negative 4. So this is the second step. 2x to the other side. You take 2x from both sides, yeah? Second one, negative 12y equals negative 6x. Take 9, divide by negative 12, and you're left with the same line. Did you do some Googling? What was the C word? The lines are... Coincident is when they're the same. Consistent is that at least one solution. Familiar with. Does anyone? So we're going to introduce a t parameter, so y equals t. So we need to say there's infinite solutions, but we need to introduce the parameter into it. So we're going to change it from the linear equations to a parametric form. So if we just rearrange for x with t subbed in, it will give us something. So now we've got y and x in terms of a parameter t. So they're in a parameter form. So if you write this as a point, they look like this. 2t minus, you can change that to 3 over 2. So that's the x, and the y is just t. So what's happening is, you've got your line, right? Your two lines, which are the same, looks something like this, straight line, and from the origin, if you sub in t equals 1, you get a point, a vector here. Sub in t equals 3, so you're getting all these different infinite solutions for that parameter.